Yo, 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 yo. Hey guys, we're going to talk about surface area. So, surface area is the sum of all the areas of all the surfaces of a 3D shape. So it's basically finding the area of the outside of a 3D object. So it's like if we took a box. So here, and sorry, I'm on my slate today. I can't get my headphones to work for the board, so my handwriting's gonna be a little bit bad. But let's say I have a box right here. Okay, so the surface area is basically if you were to take a cardboard box and you were to unfold it all. So you unfolded it, and then now you have it spread out. And normally when you spread out a cardboard box, it looks something like this. You got the two sides of the box, because this is the top that would have folded over, and then you got the other side. So if I took a cardboard box and I unfolded it and I put it flat, so it wasn't 3D anymore, it was a two-dimensional shape, flat on the ground. The surface area is the area of the outside of the box, so if I cut it, let's say I cut it like right here. Cut the box, cut a cardboard box, or unfolded it all, and I've laid it flat on the ground. It looks something like this. So then the surface area is finding the area of this two-dimensional shape when I unfold everything. So it's just the area of the outside of the three-dimensional object without filling it in. Volume is when we fill it in. We want to see how much space, how much it can hold. Surface area is just how much area is around the outside edges. Okay, so it's like taking a cardboard box, unfolding it, flattening it out so it's a two-dimensional shape flat on the ground, and taking the area of that composite figure. Okay, I hope that was an okay explanation. I know I stumbled a little bit in the beginning. Hopefully we saved it in the end. Make this a little bit bigger. So here again, I have that box that we're talking about, but now it's a jewelry box. So here are the dimensions of the jewelry box. She plans to spray paint the exterior, so she wants to know how many square inches she will have to paint. She wants to know what's the surface area of this box. She's not spray painting the inside, just the outside. So what we do is we really are just finding the area of each of these sides. So like right here, this back left side, this is a rectangle. It doesn't look like a rectangle right now, but we have to know that this is a rectangle because it's just a rectangular prism. Looks like a parallelogram right now. But I know that the height is 6 because the height over here is 6. And I know that this length is 15 because the length over there is 15. So I need to find the area of this guy, which is going to be the same as the area. And again, sorry, I'm on my slate where it's hard to be accurate. The area of this guy. These are the exact same areas, right? So I need to find the area of a 6 by 15 rectangle, and I have 2 of these. I also need to find the area of this front rectangle. Well, this one's 12 by 6. I need to find the area of a 12 by 6 rectangle. I have 2 of those because the front is the same thing as the back, because this side right here, back here, is also 12. And then I also need to find the area of the top and the bottom, which are the same, and those are 12 by 15. So I need to find the area of a rectangle that's 12 by 15. That's a terrible rendition of it, but that's okay, or drawing of it. And I have 2 of those. So this is the top and the bottom. These are the sides. I'm sorry, this is the front and the back. And these are the sides. So I'm just finding the area of these individual rectangles, and then I'm going to add them all together. So for this first one here, I have a 15 by 6 rectangle. Rectangle is just length times width. So I'm going to multiply 15 by 6, which is 90. 90 times 2 is 180 inches squared. Same thing over here. This is going to give me 72 because 12 times 6 is 72. Multiply that by 2, I get 144 inches squared. And then finally, 12 times 15. I'm just plugging it into a calculator real quick. That's 180 times 2 because I have both the front and the top and the bottom. That's going to give me 360 inches squared. So what I did is I found the area of all the outside edges, and now I have to add all of those together. So I need to do 360 plus 180 plus 144. When I add all those up, I get 684 inches squared. And that would be the surface area of this particular box, 684 square inches. That's it. Now you're going to have ones where for the surface area where they're not necessarily a rectangle. That's fine. So here I have a triangular prism. And for this triangular prism, let's look at the bottom here. I know the height of the triangle is 3. So let me draw the triangle, because the top and the bottom are the same. So my height is 3, and then this length here is 8. And I know I have 2 triangles, because I have a bottom and a top. Now I have 3 rectangles here, okay, instead of 4. I have, let me try different colors here. We have this front rectangle. I'm trying to trace, and it's really hard, sorry. This front rectangle, we know it's an 8-foot wide base, and then the height is 7. But I only have 1 of those. And then I have this right side. Oh, I meant to change the color, sorry. Missed it. That does, it looks like a parallelogram, but it really is a rectangle. And this right side is 5 wide, 7 tall. I have a 5 by 7 rectangle. I only have 1 of those, but it looks like I actually have 2 of them because this one also has a length of 5, and we know the height is 7. So that one I have 2. And those are all, that's going to account for this whole area. I have the top and bottom triangle, which we know is 3 by 8. So I got to find the area of each individual triangle. I have my front rectangle, and I have the 2 side rectangles. So 8 times 3 is 24. Divided by 2 is 12. So the area of this triangle is 12, but now I got to multiply that by 2. Do I get 24 square feet? Let's see, this rectangle right here is just 56 square feet. And again, I apologize, that's supposed to be 24 square feet. And then finally, this last rectangle is 35 square feet, because 7 times 5, but times 2 is 70. So then I got to add all 3 of these up. 24 plus 56 is 80. 80 plus 70 is 150. So the surface area is 150 square feet of this triangular prism. So just find all the shapes, find the area. So now you're going to have ones that look like this, where we have 2 different prisms stacked on top of one another. So the surface area is what you can see, okay? I mean, it's what you can see on all sides of it, right? So you could find the surface area of this bottom one, find the surface area of this top one. So this is a cube. So that makes it a little bit easier. The surface area of each side is the same. But then you notice how there's this overlap here? That means we have to subtract that bottom surface area from the top and from the bottom, because that's what isn't showing. Like the bottom of this cube isn't showing, and then the top part that's being covered up by that cube is also not showing. So here's what I mean by that. Let's just look at the top cube first. So this top cube is 8 by 8. So that means we know all sides are 8. This is 8, this is 8, this is 8. So there are 6 sides to a cube. So once I find the area of this, surface area of this, I just multiply by 6. Well, that's 64. So 64 times 6. Let's see here, 64 times 6. The surface area of an entire cube is 384 square feet. However, the bottom of this cube is not showing. So what I really could have done is I probably should have just multiplied it by 5. So I'm going to subtract 64 square feet because I can't see the bottom of this cube. It's on top of the other one, so it's not part of the surface. So really, of the top cube is 320 square feet. So that's just for this guy right here. I know this guy, oops, that's ugly. 320 square feet. So now I got to figure out the surface area of the bottom cube. Well, again, luckily it's a cube. It makes it nice and easy for us. All sides are 12. So we know there's 6 sides to a cube, and it's 12 by 12, which is 144. So each side of this cube is 144. So I'm going to take my 144 square feet and multiply by all 6 sides. I got 864 square feet. But now we got to subtract the part that's not showing. It is the part that's not showing. Notice how there's this edge right here. So part of it is showing, but part of it is missing. The part that's missing is the side that's being covered up by the 64 square feet. So I had to subtract 64 square feet from here as well to get 800. So now I have 800 plus 320 to get 1120. Okay, because again, the top of this isn't all showing. Only part of it is showing. So my final answer for this one is 1,120 square feet. Okay, that's it. So it's really just finding the area of all the shapes on the outside of a three-dimensional object. So whether it's a simple shape like so, or if it's multiple prisms, you might have to do some subtraction. But that's really it. So you have a independent practice problem that's very similar. And for things to remember, I would just use your area formulas. And then maybe redraw the individual shapes. I like to draw them out off to the side so I know what I'm finding the area of. So kind of like what I did. Let me show you what I mean by redraw. Redraw individual shapes. I know that's ugly. But what I mean by that is, like for here, I separated my three size rectangles with their dimensions so I could see what, and I realized I have times 2. For this one, I had my triangle and I had my 2 different rectangles. So I'm just redrawing the shapes and I'm finding the area of. Okay, and that's it. Hope this helped, guys. If you have any questions, please do not hesitate to ask. And that's all I got for you guys. Good to see you out.